Hello, my name is Tim Burrows, and I would like to introduce myself. I am a retired electrical engineer with a Bachelor's of Science in Electrical Engineering from the University of Texas at Dallas, UTD, a Master's of Science in Telephony from Southern Methodist University, SMU. I am also licensed as a professional engineer in the great state of Oklahoma. Go Cowboys! The following lectures target the amateur hobbyist, homeowner, undergraduate, or graduate engineering student. The lectures assume everyone has a basic understanding of the atom and basic physics, so these things will not be covered here. The lectures all have an associated lab that will cover the basics of the circuit design and analysis of the subject covered. We will cover the mathematics needed in the lab using PTC MathCAD, then build and simulate that same circuit using QUCS simulator, then build and analyze that circuit using real components and test equipment. The lecture will end with a comparison of the calculated data to the simulated data, then compare the simulated data to the empirical data we obtained. I wonder which one will be the most accurate. The goal of this format is to keep the lectures informational and fun. So enjoy. All lectures will follow the following outline. First, we will discuss the purpose and properties of the circuit, the components needed to accomplish the design, and how they affect the circuit. Second, we will show what mathematics are needed to determine the component values by using the PTC MathCAD. We'll download that from the link shown on the screen. We'll get the Students Edition, which is free. Third, we will learn to operate the Quiet Universal Circuit Simulator, QUCS. We'll download the QUCS simulator from the network that is on the screen. We will build the simulation model of the circuit, set up the simulator, and run the simulation. Then take data. Fourth, we obtain the necessary components to build the circuit. That is breadboard, wire jumpers, resistors, capacitors, etc. The following links are a good place to obtain the parts you need. DigiKey is a great source of getting chips, transistors, diodes, resistors, capacitors. I've used them many times. Jamico is another great source for electronic components. I've used them as well. Finally, I just went to Amazon, bought all the components that I'll be using in the labs. I got kits of resistor, a kit of capacitors, a kit of inductors, and all of this will be explained more thoroughly at the end of this lecture here. Fifth, we use our test equipment to take empirical data and record the results. Then we compare the mathematical results with the simulated results and then compare those to the empirical data. I wonder which one's going to be the closest to the calculated results. And that'll be the end of the lab. Now we're going to cover some common resistor types. If you look at the screen, you will see, I think, 8, 9, 10, 11 different types. We have fixed resistors, thick film resistors, LDR, which is a light detecting resistor, thin film types for precision resistors, potential meters for like volume control, things like that, trimming pots used for precision calibration, surface mount are used in high density populated boards to save on land area. Thermistors, which vary with resistance with temperature, rheostats, thyristors, and wire wound type resistors used for power mainly. The next slide shows you the resistor schematic symbols that we'll be using in the QUCS simulator schematic capture. The fixed value, rheostat, potentiometer, tapped, thermistor, and photoresistor. All the resistors have bands of different colors on them. The beginning band is opposite of either the gold or silver band, and that's your first digit. And that first digit will be the value of the color that it is. And you'll have a second band, a third band, and a multiplier. This is how we'll determine what this resistor represents. Just become familiar with this. We will learn more about this as we go along, and this will come to you easily after a while. Next is capacitors. Here's a photo of several different types of capacitor. Each is designed to meet specific functions. The trimmer cap is a prime example. It is primarily used to tune a circuit to resonate at a specific frequency. The electrolytic capacitors are used to filter voltage in a power supply. There's many kinds. Each one has a specific reason to be used in a circuit, and we will cover that more as we move on. This next slide shows you the schematic symbols for caps, the non-polarized, the polarized, and variable caps. Caps are also determined what value. They use color code bands to determine what the actual property of the capacitor is, which, as you can see from the color code graph on this slide. The next component we'll be covering is the inductor. There's several different types: air core inductors, iron core inductors, ferrite core inductors, air core inductors. These inductors have the reason the core changes because it has different permeability functions, and as we go along, we're going to find out more about this. But you have surface mount as regular as the twin axial. This next slide shows you the schematic symbols for the different inductors. We have air cord fix, air cord preset, air cord variable, iron core fixed, iron cord transformers. We have farad cord fixed, farad cord preset, farad cord variable, and farad cord transformers. The inductor uses the same nomenclature that is used in the capacitors and resistors. They have 4 bands and 5 bands. And so as we go along through these lectures, this will become more familiar, and it'll be you'll be able to determine what the value of the inductor is. Finally, to get the most benefit from the lectures, you might want to purchase the following laboratory equipment. These items are not very expensive and will allow you to experiment with what you have learned. Also, an oscilloscope and a voltmeter will need to be purchased, and they will be the most expensive if you want to get the most out of the lectures. I have provided where I obtained the lab items that we'll be using and list their prices. All experiments will use the parts out of these assorted kits, so there should be only minor new purchases necessary. We begin with the first item is the 14 values 840 piece breadboard jumper wire kit. It goes for $13.99. I bought it on Amazon. The next kit is an electrolytic capacitors. It lists as you can see from the slide, it lists all the capacitors that's in this kit, and it goes for $21.90, and also got it on Amazon. The next will be the Bojack 15 type variable 600 piece ceramic capacitor. We'll use this in all our frequency dependent circuits as we study them. It is only $12.99 from Amazon. Last but not least, the next kit is the Bojack 1000 piece 25 value resistors. It lists from 1 ohm to 1 meg ohm, and they're carbon film resistor assorted, going for $9.99. Then you will need a breadboard. I got my breadboard's different. What I have shown here, this is a Gemico value board. It goes for $25.95. I got that on Amazon as well. Here is a slide of my 2 meters. The one on the left, the green one, is a digital voltmeter, and then it measures capacitance, AC, DC resistance, ohms. And the one on the right, the yellow one, is an analog meter. Now you need an analog meter. We'll go over reasons why, but it's great for testing capacitors and checking for shorts. And it can be used to check semiconductors, transistors for being good or bad, diodes, etc. Here's the power supply that I have. It goes from 0 to 20 volts. That'll be used to power the circuit. And here's my Handtech digital storage scope 2D15 used to see the signals. The next slide shows you my DVM as sorted components, the breadboard that I have, and also the wires I'll use to make my connections. The next slide shows the book I'll be using. I had this book at the Oklahoma State University Technical Institute. It's an excellent book. All this is coming out of it. After you do any of the practices at the end of the chapters, if you buy the book, I can help you with that if you email me. So that's it for the introduction. We will begin doing labs here on after. I have about 20 labs that we can do, and then we'll move on to the next book. Enjoy.